Hello Internet, now we are going over the graph of tangent and cotangent. Okay, so let's start with the graph of tangent. So y equals tangent of x. This is basic tangent graph. Okay, we know, well, this is just a property of tangent. The graph is periodic, so it repeats, it does the same thing over again every once in a while, and that once in a while is pi. Every pi units, it does the same thing over again. And now, this is once again a graph where we are plugging in an angle and we're finding a value. The unit circle is helpful with this, but the crazy thing about tangent though is we can't just look at this and say, okay, it's x and y, but tangent is y divided by x. So we're going to have to take y and divide it by the x value, the y value. But the basic graph of tangent is very easy just to remember anyways. Tangent of theta, whatever angle, equals y over x. So you just have to memorize this graph, but it's very easy, and it also is intuitive, and that's what I'm going to show you. You could just memorize this, but if you know how it goes, then you can reconstruct it from memory, and that can be very helpful. Okay, so it's periodic, blah, blah, blah. Okay, there's a thing about tangent graphs. They have vertical asymptotes. So does cotangent, and I will show you why that is. Asymptotes. So that is a vertical line that the graph cannot cross. Okay, the lines that you make on the graph. And these vertical asymptotes, because tangent is y over x, the vertical asymptotes are wherever x equals 0, because if x equals 0, then you have y, whatever y is, divided by 0, and division by 0 is not possible. At least not in standard mathematics. So these vertical asymptotes are where x equals 0, and that is the same thing as where cosine of the graph equals 0. Okay, so let's take a look at the places where x equals 0. Okay, 2 pi, no, x is 1 there. Pi over 2, oh, look at that. X equals 0 at pi over 2. Negative 1, that's fine. Oh, 3 pi over 2, x equals 0. So we will have vertical asymptotes at pi over 2, 3 pi over 2, and then continuing just every interval of pi over 2 plus pi, plus pi, plus pi. Okay, so pi over 2 plus pi, which is 2 pi over 2, is 3 pi over 2, plus pi, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, etc., etc. And then you go backwards, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. I could just go on and on all day, but I'm not going to. So let's get down to the nitty-gritty. I'm saying it again. There you go. It's just what it's all about, man. Just don't let anyone fool you and tell you the hokey pokey is what it's all about. They are liars. Okay, so what we have just established, there are vertical asymptotes where at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2. Okay, so let's go then. Let's call this pi over 2 right here. This is pi over 2. X equals pi over 2. And right there. Pi over 2. Okay. How about 0, 0? There must be something special here. So let's say tangent of x, where tangent, y equals tangent of x. Let's plug in 0 for x. So where x equals 0, then what is y? Okay, at 0 degrees, it's y divided by x, okay? Tangent is y divided by x. So 0 divided by 1 is 0. Look at that. We have a point there, 0, 0. great, but what about the rest of it? That's not very definitive. So let's choose a point that's between 0 and pi over 2. How about pi over 4? How about that? So pi over 4 then is y divided by x. Tangent of pi over 4 is y divided by x. So square root of 2 over 2 divided by square root of 2 over 2. And we did this in the last lesson, but let's just do it again for kicks and giggles. And at this point, I kick something and then giggle. Tee-hee. Okay, so how do we divide a fraction? We multiply it by the inverse. Cross cancel. So those all become 1s. So you have 1 over 1, which is 1. Oh, that's just wonderful, isn't it? Okay, so then at pi over 4, we have 1. So let's make these points 1 and -1. -1 and 1. So you have a point right here. This point is pi over 4 and 1. Okay, how about negative pi over 4? Negative pi over 4, which is the same thing as 7 pi over 4, essentially. Okay, so it's going to be square root of 2 over 2. We're still on the positive x side, but it's in the negative side of the y value. So it's going to be square root of 2. Let's just write this down. Negative square root of 2 over 2. Okay, so now we have y divided by x. This is going to be 1 again, but because one of them is negative, then the answer will be -1. That makes sense? If it doesn't, watch it over and over and over again until you get it. Or you could just ask me, I don't know, if you know me in person. Or ask somebody who does know. Anyways, so what we have then, we have pi over 4 equals 1. And negative pi over 4 equals -1. Okay, or y is -1, where that is. So let's say negative pi over 4, -1. Ah, isn't that great? And this is not just a but it looks like the graph of x cubed, really. If you know what that looks like, which you should if you're taking a class like this. Okay, and then we can use the fact that this is periodic to say that every pi units you will have the same thing, okay? So let's go this direction because I'm out of room over here. So we have 0, 0 here, so x equals 0 here. So our x equals -pi then, we will have another x-intercept. Negative pi over 4. Let's say negative pi over 4 minus pi, okay, which is 4 pi over 4. So negative pi over 4 minus 4 pi over 4 is 5 pi over 4. So we'll have 5 pi over 4 here, negative 5 pi over 4. I'm going to forget that, so I'll write it down. Negative pi over 2 minus pi is negative pi over 2 minus 2 pi over 2, which is negative 3 pi over 2. So this is our next vertical asymptote. It's negative 3 pi over 2. And we'll have a point here. This should be, I believe this will be negative 3 pi over 4. So, and then the fact that it's periodic, we could put that there, have a point here, we'll have a point here. So this is pi away from 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 this, and so on and so on. So just take that, make it, and you can just do that infinitely, but you'll probably only need to do 1 or 2. Okay, that is tangent, and that was long, so I'm going to cut this off.